All right, second video of this topic, projectile motion. And so like all of our other second videos, we're kind of watching some problem solving go on. And so I'm going to walk through two problems tonight with you, and both of them are projectile problems. And remember, we have the two different case situations. So one in which an object is flying off of a cliff with a horizontal velocity or initial horizontal velocity. And then we have the other case in which we're actually projecting it at an angle. In our first problem, we see that we have a baseball rolls off of a 0.7 meter high desk, strikes the floor 0.25 meters away from the base of the desk. How fast was it rolling? So in other words, I know that this type of a picture, when I draw it, is going to look something like this. I'm going to have some kind of a table. Here's my floor. Here's my baseball. My baseball rolls off of this, and it falls. And the distance that I am off of the floor is 0.70 meters. Okay, and the distance that I hit on the floor was 0.25 meters. So now again, I'm back to a situation where I have two different distances, which means that I have to understand the differences between these distances. This is my distance in the y direction, and this is a distance in the x direction. And when we do these problems, I'm going to say, keep your x's on your x side, keep your y's on your y side. Okay? So in other words, we're going to do these problems, but we're going to look at it in terms of distances in the x directions and velocities in the x directions and everything that way. So in other words, I know that when I'm looking at this picture that I just drew, I have a distance, it's 0.25 meters, and that's on the y direction. And what I'm looking for is a velocity of where it left the table, and that's a velocity in the x direction, because you can see we're going in the x direction. So I'm looking for this velocity. Now, because this is a constant velocity situation in the x, remember, constant v, okay, we only need to be worried about the one equation, the d equals vt equation, and the thing I'm missing here is the t. So t cannot, I should say v cannot be found without t, which means that the t is the one thing that goes across x's and y's, because time happens in both areas at the same time. So now we have to look at it and say, well, what do we know on the y side? Well, there my distance was 0.70 meters, and I know that I'm falling, so I have an acceleration that's 9.8 meters per second squared, and I'm going to treat the downward direction as the positive direction, so my acceleration is positive. And that I hit the ground, and in the y direction, my initial velocity was 0 meters per second. So in other words, I have three of the pieces, and I'm looking now for a time. So I'm going to set this thing up and find my time. Now, because I have the distance, I'm going to go distance is equal to VIT plus 1/2 AT squared. That piece disappears, so this is now 0.7 equals 1/2 9.8 t squared, and now I'm going to solve for my t squared. So I'm going to take my 0.7, this is where you grab your calculator. Clear. By the way, at any point in time as we do these, if you wanted to attempt to try the problem before you see me do it, go ahead and pause the video and do that. I tend to just work through them and not remember to tell you to pause if you wanted to try it. So I'm going to divide by 0.5, okay, and I'm going to divide by 9.8, and so I end up getting, let me just double check that, 0.7. I get a time of 0.143, but remember that's time squared, so now I have to take the square root of that, and so I get a time that's equal to 0.378 seconds. Okay, now that's the amount of time that my baseball is flying in the x direction, and so now I can use that time to figure out my velocity. So my distance was 0.25. I'm going to divide my distance by my 0.3 0.78, and I now find that my velocity in the x direction was 0.661 meters per second, okay, as it went horizontally off of the table, okay. Alright, on to the next question. Now the next one is going to be our second case. So in other words, this is one where we have a cannonball, it's fired off the ground with an initial speed, we have an initial angle to the horizontal, and we're going to neglect air resistance. It's wonderful that we can neglect air resistance because it makes problems easier. Now what we want to do is we want to find the cannonball's range and the time in the air. Okay, so here's my cannon. Okay. Alright, and my cannon shoots. Okay, parabolic path. I'm looking for the distance here as my range. And it has an initial speed of 53.9 meters per second with an angle of 55 degrees. Now, they gave me an angle, they gave me a velocity, which means that I need to find components. Okay, so I need to find component vectors to represent this velocity vector. So that's going to be my first task, because again, I want to keep everything in the x and everything in the y separate. So I want to find my velocity in the y, I want to find my velocity in the x. So I need to set up my triangle. Okay, 55 is there. So to find this velocity in the y direction, I'm going to take the sine, okay, velocity now in the y direction is going to be the sine of my 55 times the hypotenuse. 53.9. So I'm going to take my 53.9 times sine of 55. That gives me 44.2 meters per second. So now that's going to be my initial velocity on this side, 44.2 meters per second. On the x side, I have to use the cosine, because again, I'm looking for this, and that's the side adjacent, so I'm going to do the cosine of it. So 53.9 cosine times cosine of 55 gives me a velocity here of 30.9 meters per second. And again, this is constant v, okay? So in other words, it's not just an initial velocity, it is the velocity. And we don't know the time, and we don't know the distance here. Over here, we know that, we do know that the acceleration is 9.8 meters per second squared, okay? And we will treat our acceleration to be, let's treat upward as positive this time, which means that my acceleration actually acts opposite that, so it's a negative acceleration. And let's see, what do we know? We know that as the cannonball goes to here, to this point, at this point up here, we have a velocity in the y direction. We'll consider that to be a final velocity in the y direction of 0 meters per second. Now again, why do I make that conclusion? Is because as we go this way, our velocities stay the same. So this is going back to the picture from yesterday. But our velocities in the y direction get a little bit smaller each time until we finally see that we appear to be stop ascending before we start making a turn to go back down, which means that we do have a velocity there. Now, the only thing that I don't know over here is I don't know the time, and I don't know the distance, okay? But apparently I don't need the distance, so that's the piece that I don't need. I do need to know the time, because I'm going to relate that time back over to the other side. So let's go through and find the time here. So I know that VF is 0. I know that VI is 44.2, and plus AT, so minus 9, minus 9.8 T. So again, I'm going to solve this using that VF equals VI plus AT equation. I'm going to bring my 44.2 over to the other side, so I get negative 44.2 is equal to negative 9.8 T. Divide by negative 9.8, negative 9.8, and that'll give me what T is equal to. So now I have to find out what T is equal to. So 44.2 divided by 9.8 gives me 4.5 seconds. Okay, so in other words, 4.51 seconds. So that's the amount of time that it takes the cannonball to leave the cannon and get to the top. Okay, and once we get to the top, it has to travel another 4.51 seconds to get down to the bottom. So you have to remember that this, what we figured out, was only to this point, and so that time keeps going. It actually follows symmetry. It doubles the time. So when I go back over here, I now know my time. Okay, my time is now going to be 2 times whatever the original time was. Okay, so I'm going to take that times 2, and that tells me that I'm in the air for 9.02 seconds. Now I can figure out my distance. So my distance is now equal to my velocity times my time. So my distance is equal to 30.9 times 9.02. And that gives me 279, I'll say, 279 meters. Okay, and so that's how far my cannonball was fired. Okay, again, keep your x's on the x's, keep your y's on the y's, and the x side always is a constant velocity, where the y side is constant acceleration due to gravity. Okay, until next time, happy physics.